Okay, obviously I'm gone today. I wanted to just give you guys some more practice at factoring to graph quadratics, so I'm going to do 3 of them here for you. Follow along if you can, pause the video as you go, and then you guys just have a practice worksheet when I'm done. So, first one we're looking at is y equals x squared minus 6x plus 8. So we need to find the zeros, find the values of x that make y equal to 0. So the first thing we're going to do is set y equal to 0, not 0 equal to 0, y equal to 0. Okay, then we just need to factor that. So how do I factor that trinomial into 2 binomials? Well, the factors of x squared are x, and I need 2 factors of 8 that add up to negative 6. The factors of 8 are 1 times 8, 2 times 4. Which one's going to give me a 6? It's going to have to be 2 times 4, right? Then I have to look at how do I make it a negative 6? Well, they both have to be negative. Then to just double check, negative 2 times negative 4 gives me the positive 8, and negative 2 minus 4 gives me the negative 6, so it works. Okay, the zero product property says that if any two things are multiplied and the product or the result is 0, that one of those things must have been 0. So we set them both equal to 0, and I find out that the values of x that make y equal to 0 are 2 and 4. Right? We add 2 to both sides and add 4 to both sides. So that means that the zeros are at 2, 0 and 4, 0. So 2, 0 and 4, 0. Okay, now I need the vertex. Vertex is always located exactly halfway between the two. So I'm just going to add my 2 and my 4 and divide that by 2. That gives me 8 over 2 or, 6 over 2 or 3. So the vertex is at 3, so I know that it's now right in between these two, but I don't know where at on the axis of symmetry. So I'm going to plug that 3 back into the original function. Okay, so you can do this on your calculator. Hit 3, store, and then the X button, enter, and then just type in that original function. Okay, if you plug it in, 3 squared is 9, minus 18 is negative 9, plus 8, negative 1. So it's not impossible to do by hand. So 3, negative 1. So our vertex is right there. The last point that we want is the y-intercept. Y-intercept is when you plug 0 in for x. What's the y value? It will always be this guy, 0, 8. So that's going to be way up here, right? Now, the last thing we're going to do is look at how far from the axis of symmetry is that point. The vertex is at 3, so it's 3 units away. So I'm just going to go 3 units the other way, which puts me at 6. And I'm going to mirror or reflect that point. That gives me 5 points to graph this guy with. Okay, again, make sure it's a curve, not straight lines. Okay, here's the other one. This one I want you to pause for at least 2 minutes and give this one a shot and then come back and see how I do it. Okay, so go ahead and pause it. Okay, hopefully you figured this out. The first thing we have to do is make a equal to 1. So I'm going to divide everything by a negative 1. I'm also going to set it equal to 0 at the same time. So we just change the signs of everything and it should look like that. I'm going to divide everything by negative 1, which really just gets rid of that. 0 divided by negative 1 is still 0. Now from here on out, it's exactly the same as the other one. I need to factor x and x. They're going to have 1 of each sign. Factors of 3 that add to 2 are positive 3 and negative 1. Right? Because the only factors of 3 are 1 and 3, so there's only a couple of options. That means that my zeros are x equals negative 3 and x equals 1. So negative 3, 0 and 1, 0. Negative 3, 0 and 1, 0. Perfect. Now I need the vertex. Again, the vertex is halfway between those 2 points, right? So halfway between negative 3 and 1 means take the average of the two. Negative 3 plus 1 is negative 2. Divided by 2 is negative 1. That's just the x-coordinate. And it means that the axis of symmetry is at x equals negative 1, this red line. Somewhere along that red line is the y-coordinate. I'm just going to plug the negative 1 back into the original function. Make sure you do not plug it in here. Right? We need to plug it back into the original function with that negative 1 up there. Okay, so again, plug this into your calculator. Negative 1, store as x, and then just retype negative x squared plus minus 2x plus 3. So negative x squared minus 2x plus 3. I'm doing the same thing myself. We're going to get 4. So the y-coordinate is up here at -1, 4. And that makes sense. This thing should open downward because a was a negative value, right? We expect it to open upside down. Last 2 points that we want. First, the y-intercept. Right, plug in 0 for x, but again, it's always this guy in the original, so 0, 3, which is right there. That looks right. Look at how far it is from the axis of symmetry. That's only 1, so we're going to go 1 the other way. Just mirror that point or reflect it. And then I have my 5 points to draw my parabola. Should look something like that. Okay, last one. This one is different to factor, but the process afterwards is exactly the same. Okay, so go ahead and pause for 30 seconds and just try to factor it. Go. Okay, hopefully when you factored this, you realize we can take out a common factor of -2x, which leaves me with x plus 2. Same exact process. Set them both equal to 0. The one on the right is what you're used to seeing. X is -2, so -2, 0 is one of our zeros. This one is not any harder to solve, but you're just not used to seeing it that way. Divide both sides by -2. 0 divided by -2 is still 0. That's the other one. So 0, 0 is our other 0, our other place where it crosses the x-axis, our other x-intercept. So I'm going to plot those two, -2, 0, and 0, 0. The vertex, again, halfway between those two. It's a little bit easier when one of them is 0, because obviously halfway between is -1. Plug -1 back in to the original function. So -1 squared is 1 times -2 gives you a -2 minus 4. It drops it down to -6. Double check I did that right. 1 times -2 minus 4, -6. Yeah. So it's going to be all the way down here, a little bit off the graph. I didn't make it big enough. Okay, then we need the y-intercept. Y-intercept is when x equals 0. And it's, wait, it should be something out here, right? A plus c. Well, the only thing that could be there is plus 0, which makes sense. The y-intercept has to also be one of our x-intercepts, because x-intercept and y-intercept are both at the origin. So in this case, it's not all that helpful, because if I were to reflect it across that axis of symmetry where the vertex is, it would be this point also. So in this case, we're just going to have to go with our 3 points to graph this guy. Again, you do the best thing you can there with a curve. Okay, you guys have a review worksheet to practice this. Tomorrow you will do a little bit of review over the entire chapter so far. And then we're going to quiz on Friday. Good luck.